Right, fellas, welcome to this video. This is on AP Precalculus Unit 2 review. By the way, this is a mini version of the big video. The complete video is in the link is in the description. That's a members only video, and that is 2 plus hours. Actually, there are 3 videos on all the 3 units of AP Precalculus, and all 3 are members only. So if you decide to, if you are super inspired to have a complete, as in, the horror review, then take the membership, and all the 3 videos you will have access to those. But otherwise, for a mini review, I think this video will serve the purpose. I'm going to solve almost I don't know the question, but almost all the concepts, that's for sure. We're going to solve it, and of course you can download this PDF from the link in the description, and if you need private tutoring, feel free to reach out. All right. So we're given that the values of the terms of the geometric sequence are graphed over here, in which of the following expressions gives the nth term of the geometric sequence. So we know that geometric sequence Gn is given by G1 times R to the n minus 1, either this, or Gn is also given by G0 R to the n. But I think, I'm not sure if this will make sense because we are not given G0 anywhere. So let's go with this one, the above one. G1 is basically the value at 1, which is just 4. So I'm just going to replace G1 by 4. And R is the common ratio, which is the latter term, which is negative 2, over the former term, which is 4. So that's negative 1 over 2. So R is negative 1 over 2. So the value of Gn comes out as G1 4, and R, which is negative 1 over 2 to the n minus 1, which looks like option B to me. So I think that should be our answer, if it makes sense. Okay. Right, in this question, we again need to find the equation of the geometric progression. I think it feels like these two will make sense because these two are giving me a hint that we are starting from G0. So let's write the general term Gn is equal to G0 times R to the n. G0 is 10 and R we need to find out. So just be careful here that when we find the radius, the ratio, this is for the second term and this is for the 0th term, right? So you cannot really just take the ratio of these two and get the common ratio. You have to be a little careful here. So we know that G0 is given by 10, G2 is given by 5. So if I write the equation G2 is equal to if I write the general equation Gn is equal to G0 times R to the n, and I replace n with 2. So G2 is G0 R square, G2 is 5, G0 is 10, and R square is just R square. So I got 5 over 10 is equal to R square, which means that R square is 1 over 2, which means that the value of R is 1 over 2 to the 1 over 2. Right, and this R I'm going to sub in over here. So this is going to look like 10 times 1 over 2 to the 1 over 2 to the n, and this will look like 10 times 1 over 2 to the n over 2. So that is the value of Gn, which is option C, I think. Yeah, option C makes sense. Okay, all right. A large theater has rows arranged in a way that the number of seats in each consecutive row forms an arithmetic. If the 4th row contains, okay, so I'm given A4 as 30, and the 8th row contains, so I'm given A8 as 54, then which of the following are the number of seats in the 10th row? First, we need to figure out what is the common difference. So the common difference is, obviously we can treat these 2 points as the points lying on a straight line. I hope you know this shortcut. If any 2 terms are given, then consider these as points as if they are lying on a straight line, and just find the slope, which will be your common difference. So it is 54 minus 30 over 8 minus 4. So that's I think 24, right, over 4, which is just 6. Now I need to figure out what is A10. So I know that AN is equal to A K plus n minus k times t. That's a general formula for arithmetic. So in our case, I need to find A10, so n is 10, and we can take the reference as probably either A4 or A8, whichever you like. I will take A4. So A4, k is 4, 10 minus 4, and common difference is 6. So A10 will be equal to A4. A4 is 30 plus 6 times 6 is 36. So that's going to be 66 over here. That's going to be A10. And yeah, we have that in the option. So it should be B. Okay. Let AN represents an arithmetic sequence where this happens and find the value of A12. Isn't that literally the same type of question? So I'm going to find the common difference over here, which is 10 minus 22 over 6 minus 3, which is negative 12 over 3, which is negative 4. And A12 in that case is going to be, I'm just using the general term, AN is equal to AK plus N minus K times D. A12 will be equal to A3 plus 12 minus 3 times common difference is minus 4. So A12 will be equal to A3, which is 22, plus 12 minus 3 is 9, 9 times 4 is 36, so minus 36, and 22 minus 36 is negative 14. So yes, fortunately that is in the option, so the answer is option B. Okay, the next one is the table gives values of the sequence Sn and which of the following statements about Sn is true? Is that arithmetic or is that geometric? That's the first question. Well, clearly we can see that if we take the difference, for example, 6 minus 12, negative 6, 0 minus 6, negative 6, negative 6 minus 0, negative 6, negative 12 minus minus 6, negative 6. So for sure, it is not geometric, it is arithmetic because the difference is same. And yeah, it's it. Because successive terms have a constant difference, and that's what we want. Proportional change is the property of geometric, so that's not what we want. Okay. The table gives the value of the sequence, which are the following statements about Sn is true. Again, I think the same scenario, but this time, yeah, I mean, I forgot to tell you that just make sure the n values are increasing by the same gap. Right? In this case, yes, it is. And in the next question also, it is. I'm not saying that the gap should be 1. I mean, the gap can be 2 as well. It can be like 2, 4, 6, 8, 10. I won't really mind. The gap should just be same. So here you can see that if we take the ratio 2 over 1 to 4 over 2 to 8 over 4 to 16 over 8 to so the common ratio is 2, which means that it is a geometric sequence because of the constant, proportional thing. So 8 is D. That makes sense. Okay. Now we are given an exponential function, and they are asking us that what is the end behavior. So guys, I hope you know the parent functions, that if we have a times b to the x, and if a is positive and b is between 0 and 1, which is happening in this case, the curve is an exponential decay. So it looks like this. So clearly, if we see this, if x is approaching to positive infinity, this thing is going to 0. So x is going to infinity, this is going to 0. Honestly, this is the only option that has this. But yeah, if x is going to negative infinity, it should go to infinity, which is also matching. So it should be option D. That should be our answer. Okay. What if I have a times b to the x where a is greater than 0 but b is greater than 1? This time it will be an exponential growth. So it will look like this. So it will become 0 if x is approaching to negative infinity. As you can clearly see that it is approaching, flattening out about the x-axis. So when x is approaching negative infinity, it should be 0, which is in these two options. And when x is approaching to positive infinity, it will just go to positive infinity. That is the other option, which is over here. So option C is the best choice. The function h is given by this, and which are the following decides. Don't be confused just because this is less than 1. It doesn't matter. All we care about is this should be positive, and if this is greater than 1, then literally it follows the same thing as the question number 14. So I think they have not even changed the options. It should be C as well over here, just as the above one, right? A times b to the x. And yeah, over here, just be a little careful, because although it is a times b to the x, which would have been like this, but this negative sign flips it about the x-axis. So the actual graph will be like this because it has been flipped. So when x is approaching to negative infinity, it is going to 0. Yes, that is still happening over here. But when x is going to infinity, y is going to minus infinity, which is going to be this one. So it has to be option A. That's the answer. Okay. Here we are given a table, and we need to figure out that what are the properties of A and B. So honestly, just first off, see that whether that's an exponential increase or growth or decay. Obviously, that's a growth. The numbers are increasing. So growth means A is positive. It is already given that A and B are positive. So it means that A is obviously positive and B has to be greater than 1 if it wants to be an exponential growth, which matches with option D over here, right? 22. The exponential function, again, I think the same scenario, but this time, if you notice, actually nothing. Uh, Still, it is increasing in nature, right? So I don't think so anything has changed here. It is still increasing, it is still a growth, and A is anyway positive. So yeah, I will again go with option D. A is positive and B is greater than 1. Yeah, this one definitely you can see that the y values are decreasing with time. So it is a decay, and if it is a decay and a is already positive, this means that b should be between 0 and 1. So a is positive and b is between 0 and 1 and decay. So it has to be option A. That makes sense. Right, I hope these questions are making sense to you guys. If you're liking this video so far, please like and subscribe. Please share it with your friends as well, so that it can help them and it will help me as well. Okay, which are the following statements true about this function? Now they are talking about increasing, decreasing, and concave up, concave down. All right, so this is an exponential decay. I think we both agree with that. We just saw the form earlier. Exponential decay function looks like this, which means that obviously it is a decreasing function, and it is also smiling in nature. So it's decreasing and concave up. So I'm gonna say, yeah, this option makes sense, decreasing and concave up. So it should be C. Likewise, over here, this is an exponential growth because A is positive and B is greater than 1. Exponential growth function looks like this over here. It's increasing and concave up, of course, because it's increasing clearly and it is, smiling in nature. So it should be concave up. Okay. So the following statements is true about the exponential function. This once again we are talking about a similar situation. This is again an exponential increase, guys. 3 times 5 to the x, so it will look like this. So I think this is also increasing and concave up. Nothing has really changed. Okay, 27, it is negative this time, so it would have been an exponentially increasing function, but because of this negative, it is now reflected about the x-axis. So it is a decreasing function, of course, and it is also concave down because it is frowning in nature. So decreasing and concave down is option D. And finally, this function would have been an exponential decay because this b is less than 1. But since there is a negative sign outside, so it has been reflected about the x-axis, which means that it is obviously increasing in nature. You can see it is increasing and frowning as well. So concave down. So increasing and frowning, or increasing and concave down, is an option B. So that should be our answer. All right. they're saying that this function is a quadratic or exponential. Obviously, that's an exponential, so A and B are definitely not possible. And why is it exponential? Because the values are proportional over equal length, or average rate of change can be given by a linear function. No. Average rate of change can be given by a linear function is the property of quadratic, not exponent. So D is way wrong. It has to be option C, where the ratios are same. And yes, that is indeed the property of the exponential function, right? Okay. Question number 36. So these guys are pretty important in AP. For some reason, they like these type of questions. So we need to rewrite the same question in another way. Okay. So if we keep the 36 as 36, can I write 4 as 2 square? And 2 square to the x is just 2 to the 2x, right? So it has to be option D. 36 is D. The function j is given by this, which of the following is equivalent form. So this will look like 3 times 4 to the x plus 2 is 4 to the x times 4 square. 3 times 4 to the x times 4 square is 16. And 16 times 3 is 48. So 48 times 4 to the x, which is definitely option B. All right. In the xy plane over here, okay, this is about transformation. So they are saying that if this guy undergoes a vertical dilation of the exponential function k, okay, so they are saying that this function undergoes a vertical dilation and becomes this. So what is its equivalent form of h that expresses h as a horizontal translation of k? Okay, I hope you understand the question. They are saying this is a parent and this has been vertically dilated, as you can see, by a factor of 9, and it becomes this. So can I write h but not as a vertical dilation but as a horizontal translation of k? Yes, indeed, because 9 times 3 to the x can be written as 3 square times 3 to the x, which is 3 to the 2 plus x. And obviously this is going left by 2. Well, they just need the form, by the way, which is just option B. But yeah, we can also say that it is going left by 2, and that's how you will get this option. Think this is again something that we need to manipulate, because this has undergone a horizontal dilation of 3 to the x, and that is equivalent to this. So 3 to the root 3 is just 3 to the 1 over 2 to the x, and 3 to the 1 over 2x is just 3 to the x over 2, which looks like option A. Okay. Over here, the increasing function c gives the number of cars that are stuck in traffic due to the lane closures. They are saying that if the model can be constructed to represent this data, then which of the following best applies to this situation? Okay, the way I see it, this is exponential, obviously because we are talking about 2.5, but yeah, of course, look at the common ratio, it's same, right? Every number is multiplied by 3 to get the next number, so it is a common ratio. And you can see the x values are also increasing by the same gap, right? So if it is 3, then I'm looking for an exponential function having a b value of 3, which is only happening in option D. So that should be our answer. Likewise, they are saying over here that the number of cars are increasing by 15% each hour, and at t equal to 0, there are 54 cars on the highway. So the initial value is 54, and that's why you can see that every option has a 54 over here. And every hour, it increases by 15%. So it is something like 50 times 1.15 to the t, or to the h, because h are the number of hours. But they are saying that if I now represent time in minutes, then what will be the equivalent? Okay, this is a very popular question where they give a unit and then ask you to convert it into a different unit. So if this is in hours, then if you want to convert this into minutes, then you might think that 1 hour is 60 minutes, so just replace by 60t. Actually, it's counterintuitive. 1 hour is 60 minutes, so it will be replaced by t over 60, right? That's how it works. So it has to be option C and not option D. No, the option D is wrong. It should be option C. Think about it like this. If you replace t by 60 minutes, which is basically 1 hour, 60 over 60 will become 1. And if you replace h by 1 hour, it will also become 1. And these two will be equal. And that's what I want. I want both of them to represent the same situation. So it should be t over 60. All right, guys. Function model validation, competing function model validation. All right, guys. This is, I think, about residuals. And if you remember, we talked about this earlier, that if the residuals are showing a pattern, then the model is not appropriate. Definitely there is a pattern over here. So it is not appropriate. Why? Because there is a pattern. So this has to be option D over here. So that the regression model, whichever we have used, if we are plotting the residuals, it is showing a pattern, so it is not appropriate. Okay. Over here as well, you can see that if this is the regression model over on the left, and this is the residual plot over on the right, which is obviously showing a pattern. So will we say that the model is appropriate? Obviously, model is not appropriate. It is not appropriate. And is this exponential or quadratic? Obviously, that's an exponential regression. So it has to be option D, that it is used and it is an exponential regression, but the model is definitely not appropriate. So that's how we answer it. Okay. Composition of functions. Okay, this is important, guys. So let's talk about the first question. So we are given that a table is given showing some values of f and g at some values of x, and we need to find that if h is this, then what is h of 9? So h of 9 is given by g of f of 9. F of 9 is, I think, over here, which is just 5. And g of 5 is, I think, over here, which is 4. So the answer is 4, and yes, that is in the options. Here we need to find k of 3. So k of 3 is given by f of g of 3. What is g of 3, guys? At x equal to 3, g is 5. So it's 5. And what is f of 5, guys? At x equal to 5, f is 8. So the answer is 8 over here, which is option C. Okay. Let h be defined. This is again the same scenario. We are just given two different graphs here. So h of 8 is going to be g of f of 8. And what is f of 8? If I read this, this is 8 and the y value is 1. So this is going to be g of 1. And what is g of 1, guys? At x equal to 1, it is minus 2. So this has to be negative 2, which is option A. That's how it works. Okay, over here we need to figure out k of 9. So k of 9 will be f of g of 9. What is g of 9, guys? G of 9 is over here, which is just 3. G of 9 is 3. And what is f of 3? F of 3 is going to be over here. At x equal to 3, f is minus 2. So this is minus 2 over here. So our answer should be option B. Okay. Okay, this is pretty interesting now. We are talking about inverse functions. The graph of the piecewise function f is given. So we need to, and there is a function g which is the inverse of f. So what is the domain of g? Remember that for f inverse, or for f and f inverse, the domain and range swaps. In other words, the domain of f is the range of f inverse, and the range of f inverse is the domain of f. So if they're asking me the domain of f inverse, because g is f inverse, I'm basically looking for the range of f. And the range of f is -2 to 3. So negative 2 to 3 is the range, which has to be option C. That should be the answer. Okay. The function k is the inverse of h. What is the minimum value of k? Obviously, if you're looking for the minimum value of k, you're looking for the minimum y value of k. So minimum y value of k or minimum y value of h inverse is basically the minimum x value of h because they are inverse of each other. So what is the minimum x value of h? Negative 3, clearly. So our answer is negative 3. I hope you are able to understand the logic. It's just about reversal, swapping the domain and range, and that's the only trick over here. Okay. The table gives the increasing function. What is the value of f inverse 4? So f inverse 4 means the corresponding x value of the function fx when its y value is 4. So when is the y value 4? It is at 6. So the answer is 6, which is option D. Okay. Over here, we are given the table that gives an invertible function. So what is the value of f inverse g4? G4 is pretty straightforward. This is 4. This is g. So that's 7. So what is f inverse of 7? F inverse of 7 is the x value when f is 7. So f is 7 right here. Its x value is 2. There you go. Answer is A. Okay, f g inverse of f of 2. What is f of 2? F of x equal to 2. F of 2 is just 7. So g inverse of 7. G inverse of 7 means the x value when g is 7. G is 7 right here. So its x value is 4. So there you go. 4. What is f inverse g inverse 7? Let's be a little careful here. G inverse f inverse 7 means the value of x when f is 7. So f is 7 here, x value is 2. So I'm looking for g inverse 2. G inverse 2 means the x value when g is 2. So g is 2 here, x is 7. So our answer is 7, which is option D. I hope you understand this, guys. Feel free to pause and absorb this or, watch it again, but I'm pretty sure you will get it. It's just about f and f inverse and reading backwards. And the last one, f inverse, f of g inverse 2. G inverse 2 is the x value when g is 2. G is 2 right here, so its x value is 7. So what is f of 7? Pretty straightforward. At x equal to 7, f is 5. So the answer is 5 over here. Okay. The function h is increasing and the graph of h is concave up. Let k be the inverse. Then which of the following statements about k is true? Remember that a function and its inverse are always mirror image about the line y equal to x, right? So assume a hypothetical function h which is increasing and concave up, probably something like this. If I take the reflection of this about y equal to x, it will look like this, which means it is still increasing, but now frowning, which means concave down. So it has to be option B. That's the correct choice. It was a good conceptual question, I would say. All right, guys, moving to logs. The function is given by log of x with base 8. What is f of 2? This is all no cal, guys. So f of 2 is equal to log of 2 with base 8, which can be written as log of 2 over log of 8, change of base property, which can be written as log of 2 over 8 can be written as log of 2 cube. So this can be written as log of 2 over 3 log 2. Log 2 gone, and we are just left with 1 over 3. 1 over 3 is option C. That should be our final answer. Okay, you have to find g of 1 over 9. Likewise, we are going to solve this one. Well, I'm running a little out of space, sorry. But yeah, I think I'm gonna do that over here. So that's gonna look like log with base 3, 9 to the minus 1. This can be written as minus log 9 with base 3 because log has a property that minus is thrown outside. 9 can be written as 3 square and 2 can be dropped outside. So the answer is negative 2. Why? Because log 3 with base 3 is 1. So the answer is option A. Okay, h is given by this if the input value in the domain of h yields an output value of 1 over 2. In other words, they want to know at what x is y 1 over 2. So I will solve it like this. Log of x with base 4 is 1 over 2, which means that the value of x is 4 to the 1 over 2, right? I hope you know what I did over here. Whenever you want to get rid of the log, keep the x as it is, throw the base over on the other side, and whatever is on the other side, raise it to the power. So this is going to look like 4 raised to 1 over 2 or root 4, and root 4 is just 2, which is option D. Okay. We are given that P is this, R is this. For what values will P and R intersect? So they will intersect whenever they are equal, of course. So we have to set log of x with base 10 equal to 1, which means that again, the same anti-log thing. X is equal to 10 to the 1, which means that x is just 10. So it has to be option D. Okay. Question number 81 and 82. So the function g is given by this. Which of the following statements about the inverse of g is true? Okay, inverse, how do we find inverse, guys? We replace y with x with y, and then isolate y. So let's replace y with x with y, and isolate y. So this, if we flip the omelet, this is going to look like log of y with base 4 is x. So y is equal to 4 to the x. That's going to be the inverse. They're also asking what is the domain of the inverse function. So obviously domain of inverse function is basically the range of the original function, and range of the original function is all real values, because the log function with a base of 4, whenever the base is greater than 1, looks like this. So the range is all real values. So the domain is also all real values, which has to be option C. Okay. The points are on the graph of the exponential function. Which of the following statements about k equal to log of x with base b is true? I hope you understand without even solving that b to the x and log of x to the base b, they are inverse of each other, right? And if these points are on this function, then this would mean that the x and y, if we swap, they would be on this function. I know there are no options. I unintentionally clipped it out, but the options were that which points are on the k function. So the answer will be 1 over 8 comma negative 3 and 16 comma 4. These points are on the k function because they are inverse, so x and y will just swap. The table shows the values for the function k at the selected values. Then which of the following, here's the table, guys, by the way. So k is modeled by exponential or log. Okay, so since the x values are increasing by the same gap and the y values are, if you notice, are increasing proportionally by a factor of 3. If I keep multiplying 3, I'll keep getting the next number. So obviously this is exponential because the input values changes proportionally. No, output values changes proportionally as input values increases by equal interval. So that's definitely correct. It has to be option B. That should be our answer. Okay. Which of the following statements about f is true? So for that, we need to know the graphs. This graph will be like the parent with a base greater than 1, since the base is 10. So it looks like this. So clearly this is increasing, and also clearly this is frowning. So increasing and concave down, B. This one, of course, look like just the blue one, but this negative one flips it about the x-axis because that's a reflection. So that's just going to look like this one, which is decreasing, of course, going down, and smiling. So decreasing and smiling will make it decreasing and concave up, which is C. Okay, let G be a logarithmic function. So which of the following statements about the H is true? I honestly don't really care about the vertical translations like 3 because it's not really going to make any difference in the attribute of it, like increasing or concavity. Don't you think, guys, this portion and this portion will obviously look similar because that's the same thing. The base is still greater than 1. So it is just going to match the green one, which is again decreasing and concave up. So it has to be option C. This question is about the end behavior, which also depends on, of course, the graph. So log with base 10 obviously looks like this. So if x is approaching infinity, the y value also approaches infinity, which has to be option B. And if x is approaching 0 plus, it has to approach negative infinity. So that's why option D is incorrect, right? It's just important to understand both side behavior. Okay, simplification of logs. So this is mostly about the properties of logs, guys. I hope you have memorized those. If you haven't, it would be a good idea to revise those. For example, over here, I'm going to use the property of log of A over B, which is log A as a numerator minus log B as in denominator. Okay, log of A times B can be written as log A plus log B, and this can be written as log with base to Z. Make sure to put a parentheses because later on this negative sign will be distributed, and this 3 is going to jump outside as per the properties of log. So this is going to be 3. So this will look like log of 5 with base 2. Likewise, this 2 is going to jump out. So 2 log of y with base 2 minus 3 log z with base 2. So this is going to be option B. That should be our final answer. Sorry, not B, right? 3 log 2 with, sorry, not B, C. My bad. Yeah, C is correct. Okay. Likewise over here, even if it is ln or natural log, it's not really going to change anything. So that will be ln of 2e to the 4 minus ln x cubed. This is going to be ln 2 plus ln e to the 4 minus ln x cubed. Ln 2 is just ln 2. 4 is going to drop outside. So 4 ln e, and ln e is 1. So it is just 4 and then minus 3 ln x. So 4, which is in option A and B, ln 2 and minus 3 ln x. Looks like option A, right? It matches with option A. So the following is equivalent to this one. So this is about condensing the logs. So 2 log x can be written as log x square. 3 log y can be written as log y cube, which is going to be log of x square over y cube, which has to be option C. Okay, so the following expressions is equivalent to this. So once again, this is change of base properties, change of base property of log, guys. So log of A with base B can be written as log of A over log of B. This is just a property, guys. I don't know what to explain here. It's just a property. That's how it works. Likewise over here, log of 9 with base 4 can be written as log of 9 over log of 4. Obviously, you don't see that option anywhere because this base can literally be anything. In our case, if you look at option D, the base is E. Although no one writes like this, of course. Log with base E is written as ln. So it will be ln 9 over ln 4, which has to be option D. That should be the answer. Okay. If fx is ln x, then what is this? So yes, definitely we can do this operation. So that's just going to be 2 times ln w, because f of w is just ln w, minus f of z is just ln z, which is going to be equal to ln w square minus ln z. and ln a minus ln b is ln a over b. That's the formula to condense the log, so it has to be option B. Okay, we are talking about question 106. Here function is given over here and gx is 1. So what is the x coordinate of the point of intersection of f and g? So it's as simple as solving for f and g both. So I'm just going to equate both of them, which means that log with base 10x plus 3 minus log with base 10x should be equal to 1, right? That's how you find the point of intersection. Log a minus log b is log a over b, which is equal to 1, which means that x plus 3 over x is equal to 10 to the 1, which is 10, which means that x plus 3 is equal to 10x, which means that 3 is equal to 9x, which means that 9x is equal to 3, which means that x is 3 over 9 or 1 over 3, which has to be option B. Once again, the same thing over here, that we need to find where will these intersect. So we can just do that. Natural log of 2x plus 1 is equal to 2 times ln 3, which means that natural log of 2x plus 1 is equal to ln of 3 square, because this 2 will jump on the power, and 3 square is 9. And if ln of something is equal to ln of another thing, so 2x plus 1 is 9, which means that 2x is 8, which means that x is 4, which has to be option D. Honestly, guys, these two questions are again almost similar, right? Almost similar. So I'm pretty sure you guys can handle this. Just be careful that there is an option of there is no value of x, because whatever solution you get, make sure to check that whether it is not an extraneous root. So these logs should not really go negative or something inside, guys. Otherwise, there is no such value of x, right? Just be careful with that. Okay, I'm going to solve 1, 1, 1 for you. So that's going to look like ln a plus ln b is ln of a times b. So it will be 2x plus 3 and x minus 1 is equal to ln of x square plus 6x minus 9, which means that ln of 2x square plus x minus 3 is equal to ln of x square plus 6x minus 9. If ln of something is equal to ln of another thing, it means that those two guys are equal to each other. This would mean that I will say 2x square plus x minus 3 will be equal to x square plus 6x minus 9. You can disregard these options, guys. These are for a different question. For this one, there are no options, but we are just going to write our answer as a free response. So this is going to be bring everything on one side, so it'll become x squared minus 5x plus 6 is equal to 0, which is just x minus 2, x minus 3 is 0, which means that x is 2 and x is 3. But don't blindly accept these answers. Just make sure that these are not extraneous. So if I put 2 here, yes, that's positive, it will work. 2 here, yes, that's okay. 2 here, yes, that's positive. So all good. If I put 3 here, yes, all good. 3 here, 3 minus 1, positive. 2, all good. 3 here, yes, positive. So yes, 2 and 3 are both acceptable. So this is my final answer. Okay. The same situation now, but with exponential. So with exponential, when are they intersecting each other? So I'm going to do 119 for you to start with. I want 4 to the x to intersect with 1 over 2 to the x plus 3. So I'm just going to equate them. The idea over here is, since the calculator is not allowed, you have to make sure that you make the bases equal of both the sides if possible, so that it will be easy for you to solve. I think I can do that. 4 to the x is equal to, can I write 4 to the x as 2 square to the x? Can I write 1 over 2 as 2 to the minus 1 to the x plus 3? And 2 to the 2 square to the x can be written as 2 to the 2x, and this can be written as 2 to the minus x minus 3, which means that 2x is equal to minus x minus 3, which means that adding x both the sides, 3x is equal to minus 3, which means that x is minus 1. So it has to be option C. That should be the answer. All right, I'm going to solve this one for you. This one looks a little interesting. Question 120 and then question 122 as well. I think that looks 123 actually. So 3 plus 2 times e to the minus x is equal to 11, which means that 2 times e to the minus x is 11 minus 3 is 8. Dividing both sides by 2, it's e to the minus x is 4. But honestly, but guys, this here you cannot make the bases equal. So in such cases, since you need to bring x down, you need to take log with the same base as the base of the exponent on both the sides. In other words, take natural log on both the sides, which means that over on the left side, negative x is going to drop down and ln e is 1, and this is equal to ln 4, which means that x is minus ln 4, which, yes, fortunately is option C. And finally, question 123, we have this equal to 12. So 3 times 8 to the x is 12. Divide both sides by 3. So 8 to the x is 4, which means that now 8 and 4 cannot really be converted as a 1 of 1 to the 1 as a power uh, to give another one, but both can be converted to a third person or a third number that will be a power, that these will be a power of the same third number, which is 2, because 2 cube is 8 and 2 square is 4, which means that 2 to the 3x is 2 square, which means that 3x is 2, which means that x is 2 over 3, which is option D. Alright guys, I hope these questions were helpful. Once again, this was a mini review. The total review is 2 plus hours. The link is in the description. That's a members only. And in fact, there are 3 big videos on all the 3 units. So if you take the membership, you will have access to all 3. I hope you liked this video. If you did, please like and subscribe, share it. And also, if you need private tutoring, feel free to reach out. I'll see you guys in the next video. Bye-bye.